Hello, everybody. My name is JJ from Mythical City Games, and welcome back to episode 4 of our YouTube tutorial series on making Unity games with generative AI. So we're back to Snow Fortress Rush, which is our mini game version of Snow Fortress 2, which is the game we recently released for VR. Since the last time, I've gone ahead and added in a couple little things. One is a little bit of a nice particle effect, so you can see it's snowing now in our scene. I've also added a cannon model for our enemies for now to shoot snowballs at us. So this is what's protecting the snow forts. So you can see here there's a cannon that rotates towards us and it shoots snowballs when we get close. And of course we can throw our snowballs as usual. I've also added a little particle trail to the snowballs so you can see them a little more clearly. But one thing that you'll notice is that once the snowballs are destroyed, the trail is also destroyed immediately with them because the trail is attached to the snowballs. So let's find a creative way to solve this. One thing that would be fun is to let the snowballs bounce off of things and live a little bit longer. So we're not going to destroy them as soon as they have a collision, and instead we're going to let them get automatically destroyed a little bit after, which will let their trail finish as well. So to fix this up, let's see if we can try out Unity Muse, which is Unity's AI system. So I've got it open right here, and we can explain a little bit about the game as well as provide our existing code. Okay, so we'll copy over our snowball code and let's paste that in. So it's created some code here for us. What I'd asked for is I'm making a 3D game where the player can throw snowballs. However, when the snowballs hit something, they are immediately destroyed. Can we change this to destroy the snowball after a few seconds after the collision occurs? Here's the way that it's set this up. So it's given us a public float here to define how long the delay should be after the snowball is destroyed. And it's adjusted our code a little bit. So let's go ahead and just copy that. Go back to Visual Studio and we can replace our old code. Okay, so we're back in Unity. So now the snowballs bounce off a little bit. They have a little bit more of life to them, and they live a little longer, so it's not as awkward when the snowballs get destroyed. So next, what I'd like to add is a little bit of a game state. So we want to know whether the game has been won or lost, whether the player has died, and a way to restart the game as well. So we'll need this for testing, but also obviously to give the player a goal to finish the game. If we go back to Unity Muse here, let's explain the game again. Okay, so I'm creating a 3D game and the player controls a snowman and is able to throw snowballs. The goal of the game is to reach the enemy fortress that is protected by walls of snow blocks. The game is based on physics, as the snow blocks, snowballs, and player snowman are all physics objects. I would like to add in a game state system to control whether the game has started, if we are paused, or if the game is over. I currently have a script on the player that calls a death function when the player has died. Can you help me with this? So what it's done is kind of given us a bit of an outline of what we should add. So the game state system, create an enum to define our different game states. This is great. In your main game controller script, create a variable to hold the game state, and set the game to starting at the beginning of the game. So let's go ahead and see if we can create the script for us. So now I've asked it to create this game manager script for us that'll handle the game states, and that other scripts will be able to subscribe to this and find out what's the kind of current game state right now, and functions to be able to handle changing those game states. Okay, so let's take a look at this. Here's our enums for, these are our different game states, and we've got events set up for subscribing to the game state changes. What we're going to need to do is create a new script, of course. So here's our game manager. We'll open this up. Okay, and let's paste in our new code from Muse. And then it looks like on start, it actually go ahead and triggers the starting game state. So we don't necessarily want to do that right away. We're going to want to add some UI that lets us do this. So I'm going to go ahead and get rid of this. Now we also want to be able to let our other scripts read that game state. So for example, we don't want to be able to move the player. We don't want to throw snowballs, anything like that, if we are not currently in the playing state. So let's go ahead and explain that to the AI. Okay, so I've asked it if it can give us some code that we will be able to use to subscribe to these events and to be able to check the current game state. And we want to use a singleton pattern for this, which means that we will only have one game manager in the game, and we want to be able to easily access it from other scripts. Okay, so it looks like it's generated some code for us here. So it's given us code for the beginning of our game manager class. Okay, so it's given us this new awake function, which initializes the singleton pattern here. And let's take a look at what else it's got for us. Okay, so it's given us an example of how we can subscribe to this. So we can use this code right here. And let's do that in our snowman controller. So we can restrict and change the state of the snowman based on this. So I'm going to put this into our start function and handle game state change. So we're going to need this line of code here. And this is the function that'll get called anytime the game state has been changed. For now, it's not doing anything except for just printing the new game state, but that's great just for reference. And then also it's written a function that allows us to check the current game state with some placeholders here. And then an onDestroy that's going to unsubscribe from this, so that from objects that have been destroyed, we don't have this reference anymore, which could cause errors. Okay, so in this case, we want to be able to restrict the movement and things like snowball throwing as well, based on the game state. So what we can do is we can check the game manager current game state. A nice way to do this is to create a new variable here that we can control movement that's not necessarily just relying on the game state, because we may enable or disable game movement based on other factors as well. So to do that, I'm going to ask Copilot, which is built into Visual Studio Code, to be able to write this getter for us. And we want this to be a bool movement enabled. Okay, and it's gone ahead and just suggested this code for us based on its understanding of our existing code. That's a nice way of being able to combine some of the different AI systems, because this would kind of take a while to explain to the AI in something like ChatGPT or to Muse. It's just a very simple line, a couple of lines here that I want added. So it's much better to just write a quick comment in here, and then Visual Studio Code will go ahead and get GitHub Copilot to just generate that for us. And I don't have to explain all of the other code that we have this game manager and everything. All right, so we've got this movement enabled getter, and then we can check that before we actually do the movement. And it suggested that as well for us, so we didn't even have to type it in. The Copilot understood that if we have a movement enabled check, we may want to be checking for that before we actually do our movement. So we've got that code set up. Let's see if this part works. Okay, and we're going to need a game manager in our scene. We don't currently have one yet, so let's go ahead and create just an empty object. I'll just reset its position because it doesn't matter what its position is, but it's a little bit cleaner. And we will add our game manager script to this. And then also for important objects like this, I like to create a prefab out of them. Even though there will only ever be one of these, having them set up as a prefab allows us to just change the prefab, and then this object will be modified in all the different scenes that we use it. Instead of us, let's say we want to add something else to the game manager, like another script on here, or we want to change its position or something like that, and we want that to apply to every scene that we use this object in, then if it's not a prefab, we'll have to go into every scene and actually modify it. But if it's a prefab, you can just change it once and it'll be modified at every case that you actually use it. So hopefully we've got all of that in there. Let's go ahead and run our game. Okay, so we cannot move. There's no rotation. We can still fire because we haven't added that code to the snowball thrower script, but we can't move or rotate. So let's go ahead and add some of that code to our snowball thrower as well. And in the same way, we're going to want to add in subscription to this. So subscribe to the game state change event. Okay, it's already written all that code for us. Let's create that function. It's already written all of this code for us because it's been written in another script, so it understands that we want to add the same thing to this script. And we also want the same on destroy. I'll just start it, prompt it a little bit here, and then it fills in the rest of the code to unsubscribe from the event, just like the way we've had it in our snowman controller. And again, we also do want to add in getter. We're getting the current game state. So it's gone ahead and done that, called it throwing enabled, just so we've got movement enabled here. And it's going to check whether the current game state is playing. And then we can, of course, add that check in here just by letting the AI fill in all of this code for us. So we won't be able to throw snowballs. Let's go back in and make sure that's working as well. Okay, so now I can click and I can't throw it because the game state is not yet playing. So one of the other things is that we're going to need a way, UI, to actually set that game state. What I'll go ahead and do is add this same functionality to any other scripts that need it. Okay, so I've added this to some of the other scripts that we need this same functionality. Now let's add a bit of UI so we can get the game started. So we'll need a start game button. So I'm going to go back to Unity Muse since we've already got this same chat going here where it understands the game states. And I'm going to add in instructions about adding some UI to the game. Okay, so I've asked it to help me create a new UI button that's going to trigger the start game functionality and a new menu as well. So we'll need a new script that I've asked it to create called Menu Manager that will handle things like this start game and other functionality from other buttons we add later on. Okay, so it's generating all of the instructions for us as well as the code. Nice thing about Unity Muse is it does give you references for everything that it's generating. So you can always look up some additional information about these things. Okay, so we're going to create a new script. Here we go. It's going to be called Menu Manager. All right, so we can paste over that. So it looks like we're going to need a button, and it's created a listener for that button. And then when that's called, it will call this function. Now, one thing I like to do is just clarify this with renaming so that we know that this function is getting called when this button is pressed. We'll just replace that there so there's no error. So now we'll go to Unity. And if we don't know how to set up a UI, it's got all the instructions here for us. So create a new canvas, rename it to Menu UI, add a UI button, and so forth. So let's go ahead and do all those steps. So we're going to create a new canvas. Now we already have an existing canvas, but that one is going to be used for our player HUD UI. So I'll go ahead and rename that one as well. So that's our menu UI. And then this is going to be our give all the heads up and display information for the player. Okay, so there's our new UI. We're going to use the same setup as the previous one. So that's screen space overlay, and switch this to scale with screen size. Value of 0.5, and then this way our UI will be consistent across the different HUDs, the different UI canvases that we've created. And then next, we're going to go ahead and create a button, UI button, and this is going to be our start game button. Now, before we can use this, we have to import TextMesh Pro, which is a Unity plugin that allows us to create better quality text throughout the game. This is automatic. The first time you create a UI element that requires TextMesh Pro, Unity will prompt you to import this plugin and set it up. And we've got our button here. We'll rename it to Start Game Button. And we'll also change the text on the button. And let's add our script that we just created, Menu Manager, and reference this button so that it knows what to subscribe to. And of course, we can style these buttons. So we've brought in some of our existing artwork from Unity, from Snow Fortress 2, and we can use that to create buttons. So let's go ahead and change it to this style. Now, this button is a sliced artwork, and it's currently not set up to be sliced. So you can see it just stretches out here the edges, so it doesn't look great. Let's go ahead and finish setting up this UI. To do that, we can select the sprite itself, the original sprite we imported, and go to the sprite editor, 2D sprite package from the package manager. So we'll go back to our package manager. We want to go to the Unity registry, 2D sprite package. We'll import that. Okay, so now that's in our project. Let's see if we can go ahead and edit our sprite. Open up the sprite editor. There we go. And this way, if we have sliced artwork, we can let the UI know how the slicing is set up. So in this case, it is all of the edges that are going to be sliced out. And this lets us make a button of infinite size and scale without losing the quality. So there's not going to be any stretching going on these outside sections. All of the stretching is going to happen within the middle sections here. So this kind of cross in the middle. And then we can set this button to use this style now that it's been set up like that. So instead of it being a simple image, it's a sliced image. And we have to set what is the scale of our artwork here. And this you kind of have to adjust based on your actual UI artwork. So you can see this. What this does is it controls the sort of the thickness of the outside area. Now I can make the button a little bit bigger too. And our font is really not that great, so let's bring in our font from Snow Fortress. So I've imported our fonts over here and set them up. And let's see if we could use this font, one of these two versions of it here. And let's make it white so it's nice and clear. Okay, so we've got ourselves a nice little start game button, and the functionality should be set up to trigger that button. So let's go ahead and test it out. Okay, so again, we can't move or do anything until the game's been started. Now, one thing that happens right away, as soon as we click somewhere in the game, our mouse disappears. This is because we have code to lock our cursor within the game so that we don't see the mouse cursor when we're moving our player. But if the menu is up, we should be able to see our cursor. So let's add in a little bit of code there. Now it looks like our cursor lock state is controlled via the Snowman controller script. That's probably not the best place for it because it really is not necessarily restricted to just that. So let's move this to somewhere more general. We'll put this in Game Manager. And what we can do is we can control this based on the game state. So I've explained to GitHub Copilot, just in a simple comment here, that I want to lock the state of the cursor when the game mode is playing and otherwise unlock it. And so it's written us this simple line of code. Okay, so we have our mouse cursor still. This is great, it's not locked away. And we will press the start game button. And now we have our control, the cursor is gone, and throwing now happens. However, the start game button is still showing, so we need to get rid of that. We can go back to Unity Muse, which created this UI for us. Okay, so I just asked, can you hide the start game button when the game starts? So it looks like it's added the code and it's told us what it's actually changed here. Oh, looks like we've got an error with Muse that has hidden our results. Okay. Let's see if we can regenerate this. So it doesn't look like in Muse there's any way to regenerate the same question. What happens if we copy this? Let's try that. Well, this is an early access sort of beta product, so you can expect a couple of issues like this to come up. Okay, but it looks like it's gone ahead and actually regenerated the code for us. And it's offered us a couple of options here. So it said you can just do this when the start game button is pressed, you can turn it off. But if you want to make it reappear when the game ends, for example, if the state is changed, we can add some different code here. So we'll just replace this start game. And that was a great suggestion, where something we didn't really ask for, but it's actually good code that it suggested for us to add. So we'll go ahead, put that in here. Just rename this button again. Okay, and let's add in some of the other code. I'll replace the start function that has the existing part here. And we've got our subscription like we do in other places, and we'll need an onDestroy. It's going to remove our listener and unsubscribe from this as well. So we've got our button as before. We'll hit start game, the code button's gone, and the game has started now. Okay, cool. Looks like now we need to add a way to end the game when the player's been killed. So we have that inside of our player health, that if they take damage, they will die. Currently, all this does is prints this message. So now let's go ahead and use our new game manager code to trigger the end game state. Okay, great. Let's start the game, and we can throw snowballs, we can get hit, and now the game's over, and our start game buttons come back. We no longer have interactivity, but we've been able to get our mouse cursor back. Now we're going to want to be able to restart the game, not just continue from where we left off here, because the health is obviously not going to be reset. The player is now continuing from where they were instead of restarting back at the beginning. So to do that, let's add in a restart game button that's going to reset the level for us. So I've asked it to create a new button that'll restart our game, and when the button should be shown. So it should be shown on the ending game state, and then when it's pressed, we should restart the game as well. So it looks like we've got our change to the game manager, a new function to restart the game. Let's copy that in. And since we're using the scene manager, we will also need to add this using statement up here, so we can perform scene management tasks. And now let's take a look at what else we need to change here. So it looks like we also need to create a new button. So it's got instructions for us. I'm not sure if this actually finished generating or not, but let's go ahead and just start with this part. So here's our new restart button in our menu manager. We want to turn it off at the beginning. We also are subscribing to a function, restart game. Looks like it didn't finish generating that. So let's just put in this first part, and we can use Copilot to help us finish this part off here. In this case, it's gonna call it restart game, but let's do it, follow our style, restart game button pressed. And let's create that as an actual function. It looks like it's actually gone ahead and suggested that for us based on the new code we added above. And it's also suggested what function to call inside the game manager. And let's go back to Unity and set all of that up. So since we want the restart button to basically be the same as the start game button, or in the same place, we can, in the same style, we can just copy that, change the text, and make sure we assign a reference to this new button, restart button. And we want to make sure that we're also hiding and showing the correct buttons through our menu manager here. So let's take a look at that. So on the game state change, we're still setting the start game button to active. We don't want to do that. We want to do the restart game button. Just by deleting that previous line, it looks like Copilot detected what we wanted to do and suggested the correct line of code, which would be show the restart game button. We also want to make sure that the restart game button is hidden when it's pressed, just like we do with the start game button. And let's take a look if we run the game. Okay, so we've got our start game here. Our game is started. And if we die, okay, great. So it looks like our restart game button's shown up here. We can now press that, and it's going to reload our game from the beginning. We're back to having to press start game as well. And we've got our functionality working here. So let's add some text to show whether the player has lost or won the game. Unity Muse, and ask it to generate a little bit of this UI code for us. So I've asked it to create this new UI text for us so that we can display whether the game has been lost or won, and to add this information to the game manager. So we need a way to track the current game, whether the game has been won or lost. Let's take a look at this new code. So we've got a time limit. So it looks like that's the way they wanted us to determine whether the game has been won or lost. We don't necessarily want to run this on a time limit just yet. We can do we can set that state because the player has been killed. So it looks like we've got our bool here for setting whether the game's been won. So let's copy that over to our game manager. It's player 1, and then we can do this on game over. We can. Looks like they've added change to game over as well for us. So we've got this new game over functionality. And it looks like we have an error because game over now requires us to tell the game manager whether the game was won or lost. So in this case, in player health, let's say that the player has lost, so we're false on that. And we also need to make sure we set this as a public function so we can trigger it from other places. Okay, so now we've got our game over. That will trigger this game over state and that the player has won or lost. And let's see what's next to add. We need to add our outcome text, okay, in our menu manager. Okay, and let's replace, looks like this entire function. Handle game state change. So on the ending, we're going to be setting our restart button to true. Looks like it's added back in the start button. Make sure it's turned off on that state. And it's created this text here. Let's go back to Unity and add our actual text item. Okay, we've got our menu and we can create a UI text object. Game outcome text. Okay, we want to use the same font that we used before. And let's find a place for this text. So maybe something aligned to the top a bit. And we do want this to be center aligned as well. It's a little bit hard to read this text in this color. Okay, so now we've got our big game over text here. We can assign that. And what it's created is it's done this as a regular text object, not a Text Mesh Pro. So we didn't specify that. Let's go ahead and fix that ourselves. So we have to be able to access Text Mesh Pro, which is the more advanced text system than just the regular Unity UI text. And we will change this text outcome text object to use Text Mesh Pro. Let's go back to Unity, and then we should be able to assign that. Okay, and there we go. Now it's set up. Now, one other thing is we don't want this text to be on screen right when the game starts, or maybe we want this to say something different. So let's come back in here. And on start, let's just set this text as something else. And let's see what that looks like. Okay, so our text is gone. We'll start the game. Let's get your snowman killed. There we go. And you lose. Okay, so our text shows up. If we restart the game, it reloads, and we are ready to play again. Okay, so the only thing missing from that is now a goal to reach to have a game win state. And for that, once the player is entered into the town, then we want to trigger that state. So the goal is going to be to get into the town, which is the goal in Snow Fortress 2, to stop the snowmen from entering your town. So this should be the opposite. Let's go back to Unity Muse and we can ask it to add a system to handle that. Okay, so what I've done is asked it to change the code from the game manager not to use the timer and instead use a way of reaching a certain location. So let's see what it generates. So what it's suggested is when we reach a specific location, this can be achieved with a win zone in the game. You can create a win zone script, attach it to a game object like a trigger collider in your scene to represent the win zone. Okay, let's go ahead and copy over this new code. Looks like it also has not finished generating the rest of its response. But again, this is an early access product, so there are going to be some issues with this. Let's go back to Unity, create our new script. That's going to be called the win zone. Okay, and we will open that up and copy in our newly generated code. So this is going to compare once the trigger has been entered, if it's the player, and if so, just call game over true, i.e. that it's won the game. So now we have to create this object, and that means so this is going to become a trigger object. What we're going to do is create a new 3D object. So this can be, let's say, a sphere to keep it simple. Call it the win zone. And here we don't need this to be visualized for now, so we can turn off the mesh renderer. And let's make this a little bit bigger, maybe a 10 by 10 by 10. We'll add our script. wind zone. And for this, we also need to make sure it's a trigger collider. So that means this collider is not going to stop our snowman or objects from hitting it. It's not going to create collisions. It's going to create trigger events when something touches it. And then, so that's what we can use for events like this that get triggered when something touches something else. So let's move this object a little further here past our turret for now. And let's see if this works. Okay, start game. Let's avoid the snowballs and enter our win zone. There we go. We won. Okay, if we restart, we can now avoid the snowballs. We can be killed. So let's put some of these things all together. I'm going to move the win zone into the actual town. Here it is. And let's activate our wall generator so that we have this nice wall. Let's duplicate our turret so that we have 2 turrets to fight against. Okay, so we've got our actual barrier here, our wall. We've got 2 turrets. Let's hit start game. And looks like now we're being shot by both turrets. We can try to break through the wall here. And to do that, aim. And there we go, we've broken through. And we're in the city. We won. Okay, so this is just a pretty simple example of a level design. It shows all of our functionality, so the ability to be able to avoid objects, have snowballs thrown at us, to be able to destroy the wall and get through the wall, and then to have a win state when we actually reach the town. So next up, what we're going to want to do is add a little bit more level design to this, perhaps add some power-ups and other gameplay features. But for this episode, that's all we're going to do today. Don't forget to check out Snow Fortress 2, the VR game that's currently out on Steam, Quest, and Pico, and I'll see you in the next episode.